Okay, the A part of this question is pretty straightforward. No problems with this. We set up the tree. Lunch from home 0.63. That means that bought lunch 0.37. And then you have to calculate the probability that a randomly selected student from the survey had a lunch containing fruit. So we're dealing with this branch here and this branch here, and we're going to times them and then add them together, and we'll get that. And that's not an issue. That's just the achieve part of the question, and that's pretty straightforward. Okay, the next part, the B part, which is a merit part, deals with conditional probability. Now we can still use the same tree diagram that we've already created, but now the question is calculate the probability the student had a bought lunch if they were found to have a lunch containing fruit. So suppose that a randomly selected student from those surveyed was found to contain fruit. So this becomes your conditional probability. Okay? So we'll say condition is lunch containing fruit. So that's the condition, given that they have a lunch containing fruit. So we'll make that B. Make that B. Okay, and the probability of B we've already calculated in the previous question, which was 0.7031. We've already done that. And so the conditional part of the probability is that if we move this thing over a bit, you have to have a probability of, with conditional probability, the formula is this right here, probability of A and B over the probability of B. B is your condition. So that's the probability that they have a lunch containing fruit. Now the probability of A and B is the probability that bought lunch and that they had fruit. So that's what you have to calculate. And so we're going to use this formula, and we're going to figure out what the probability of A and B are, the probability that they bought a lunch, which is 0.37, and that they had fruit. So that's 0.37 times 0.47. So that's that part. That's the top part. Okay? And then you have to put that over the probability of B, which we've already calculated. All right? So let's just erase all that stuff and do this again. So the probability of A and B that they have bought a lunch, 0.37, and that they have fruit in them is 0.47. And then that's the probability of A and B divided by the probability of B, which is the probability that they have fruit in the lunch, which we've calculated from the previous question. And that's that. So if you want to check your work to see if you've got it right, here is the answer here from the calculations. Now the C question requires that we build a new tree diagram. A survey the previous year showed that 72% of the students surveyed had fruit in their lunch. So this is where we're going to do fruit, no fruit, and so on, and we're going to build a tree diagram based on that. So this is fruit, no fruit. So 0.72 of the students surveyed had fruit in their lunch. Of those students who had fruit, it was found that 56% also had juice. So of the ones that have fruit, so that we can continue on with the branch, we have juice and no juice. And by the way, if we want this branch down here, we simply go 100 minus 72, and we'll get 28, so that's 0.28. And of these students who had fruit, it was found that 56 had juice, so this is 0.56. And we can finish this off, all right, and draw it and sort it out up to this point if you want. So if you've got 100 minus 56, you're going to have 444. So 0.44 had no juice, and so on and so on and so on. And then if you need this branch over here, you can do juice and no juice, and so on. So we've got this drawn. Okay, so let's look at where we are with things, okay? Survey the previous year showed that 72% of the students surveyed, 72% had fruit in their lunch, so that's 72% that had fruit. Of those students who had fruit, 56 also had juice. All right. Only 12% of the students who did not have fruit 12% of students not fruit in their lunch had juice. So this is where your 0.12 is going to go. Okay, so we'll just move that into here, and then the 0.88 into here. So we've basically got a new tree diagram based on that. It was also found that in a survey that 60% of students who had both fruit and juice, okay, both fruit and juice, which is here, had bought their lunch. So we put a branch out here, I've run out of room, but 0.6, and they bought their lunch. Bought lunch. So let's finish this thing off. Okay? So calculate the probability the student had a bought lunch containing fruit, given that they were found to have juice in their lunch. Given. All right? Given. So given that they had juice. So the probability of B is simply the fact that they would have juice. So in their lunch, so there's a number, the possibilities of having juice is this possibility and this possibility. So if you take a look at the answer, the question, you simply take 0.72 times by 0.56 plus 0.28 times 0.12, and that's going to give you the bottom part, which is the probability given that it had juice, and that's all the probabilities combined that they had juice. Now on the top, the probability of A and B, all right, is calculate the probability the student had bought lunch containing fruit. So bought lunch containing fruit. So a bought lunch containing fruit is right here. Bought lunch, 0.6, and contained fruit. Had fruit, had juice, 0.6. So that they had bought lunch containing fruit. So down here, if you take the top, 0.72 times 0.56 times 0.6. And then you divide that, and you'll get your answer. And you can round it to anything that you want. But that's the question.